What's up, scholars? Today we're talking about law of sines. We're going to do 3 different types of examples here. This first one says, in triangle OPQ, side Q is 970 inches, P is 770 inches, and angle P is 160 degrees. Find all possible values of Q to the nearest 10th of a degree. So first, I'm going to draw a picture of what's going on here. All right, so I've got this set up. Angle P is 160 degrees. Side Q, which is across from angle Q, is 970 inches. And side P, which is across from angle P, is 77 inches. And we're going to use the law of sines here because we know 2 sides, 1 angle, and we could find angle Q using, again, our law of sines. So let's set it up. So we're going to do sine of Q over side Q is equal to sine of P over side P. Let's plug in our number. All right, so Q is 970, P is 160 degrees. We'll have sine of 160 over side P, which is 770. Now we're trying to get Q by itself because we are looking for all possible values of Q. So let's get the sine of Q by itself first, and then we'll take the inverse sine of both sides. So to do that, let's multiply both sides by 970. Multiply by 970 on the both sides. Kind of got squunched in there, so we'll have sine of Q is equal to 970 times sine of 60 over 770, and then we'll take the inverse sine of both sides to get Q by itself. Q is going to equal the inverse sine of 970 times sine 160 over 770. Let's go find ourselves a calculator on the internet to do this difficult calculation. In this case, I think Mathway is a great choice. We've got sine inverse of 970 times sine of 160 over 770. Plug it in. What do I want? I want a degree here, right? We should be getting an answer in degrees. And Mathway says, oh, this gave us the degree of the function. That's very funny. Let's try this again. I'll put x equals sine inverse of 970 times yada yada. Solve for x in degrees because we're looking for an angle measure here. Solve for x in degrees. Let's see what she says. Much more reasonable. 25.5 degrees. Okay, got it. Okay, so we've got x equals 25.5 degrees, but remember sine is positive when y values are positive. So sine is positive in the first and the second quadrant. So technically there's another answer in the second quadrant. So we just found the x equaling 25.5 degrees, which I've drawn over here in the first quadrant, but there's another triangle that would give us that same measure here over on the other side. To figure out what that guy is, we would need to do 180 minus the angle we just came up with, that 25.5 degrees, to get this additional angle that would give us the same measure. So we'll do 180 minus 25.5, and that would be our other possible answer. So our other possible answer, again, because sine is positive in the first and second quadrants, would be 180 minus the answer we just got, which would be 154.5. There's one other thing we have to consider here. What do all of the angles in a triangle add up to? 180 degrees. So, okay, I just pressed the wrong button and we're no longer on the same problem, but we're going to finish what this would be. So the angles in every triangle should add up to 180. So we know one angle is 160. What we found using our law of sines was a 25. First possible angle, 160 plus 25.5. That's bigger than 180 already, right? So that's 185.5. And definitely, if we tried to do 160 plus 154.5, that's way bigger than 180, right? Way bigger than 180. So we actually have no possible triangles would be our answer. You're going to type in right here, no possible triangles, no possible, maybe the empty set. We just type in the empty set. Don't use curly brackets. Press the minus. Press the minus. Just like that. No possible triangles would be what we would submit. So let me recap what we did. We drew a picture of the triangle that we were given. We set up the law of sines based on the information that we had. We rearranged to get sine of the angle we were looking for by itself. Sine of Q equaled 970 times sine 160 over 770. We did the inverse sine to get Q by itself. We found X equaled 25.5. We found the other possible value for X because sine is positive in the first and second quadrants by doing 180 minus the answer we got. But then we realized none of these are going to work because the angles in a triangle need to add to 180 degrees. And if we take the two angles, one that we were given and one that we were found, add them up, we're already bigger than 180, which is not going to make a triangle. So our answer was the empty set, these curly brackets, which we got from pressing that minus button. All right, question type 2, finding the area. In triangle QRS, Q is equal to 1.2 centimeters, R is equal to 1.5 centimeters, and S is equal to 2 centimeters. Find the area of QRS to the nearest square centimeter. Psych, try again. That would have been a law of cosines. That'll be for next section. Try this one more time. We're going to do triangle FGH. F is equal to 5.4 centimeters, H is equal to 13 degrees, F is equal to 131 degrees. Find the area of the triangle to the nearest tenth of a centimeter. So first, let's draw our picture. So here we've got our picture. Angle F is 131. Across from it is side F, which is 4.5. We've got angle H, which is 13 degrees. And we are, of course, going to be using our equation for the area, which is area is equal to 1/2 AB sine C, where C is an angle and A and B are the sides adjacent to that angle C. So in our case, we have side F. We need another side, but we need to be strategic about which side we're going to find here because we need an angle in the middle and two sides next to it. We know this angle 13 over here, but we don't know the side across from it. We could easily figure out angle G because all the angles in a triangle add up to 180. So let's do 180 minus 131 minus 13 to get angle G. So 180 minus 180, whoa, Lord, clear it all. 180 minus 131 minus 13 is equal to 36. Okay, great. So angle G is 36 degrees. And now we could use our law of sines to figure out side H, in which case we would have an angle, 36 degrees, and two sides that form that angle that we can use in this area problem. So let's use what we've got. We know angle F, we know side F, we know angle H. We can use that to find side H. So we've got sine of F over F is going to equal to sine of H over H. Plug our numbers in. So we've got sine 131 over 4.5 equals sine 13 over H. Let's do some algebra gymnastics. Multiply by H on both sides and divide or multiply by the reciprocal of the sine 131 over 4.5.